Let's write an exciting program to print the numbers from 1 to 10. We can use a for loop to print the numbers from 1 to 10. We can replace the loop with recursion that does the same thing. There is no base case. There is one recursive call in line 3. We stop recursion when n becomes 0. We can see the output of the iterative solution. Recursive program needs a parameter that is updated in each recursive call. We can see the same output for the recursive solution. Let's write another exciting program to print numbers from 10 to 1. We can use the down to method to print the numbers in descending order. We can replace the loop with recursion that does the same thing. There is no base case. There is one recursive call in line 4. We can see the output of the iterative solution. We can see the same output for the recursive solution. Let's compare the recursive solutions to ascending and descending printing of numbers. This is head recursion. The recursive call happens before some work is done. This is tail recursion. The recursive call is the last action. In head recursion, we need a stack frame to maintain state. In tail recursion, we don't need to maintain variables in a stack because we have completed the work we need to do with variable n. In head recursion, stack will grow with the number of recursive calls. In tail recursion, stack will not grow. Compilers can optimize code by converting tail recursion to an iterative solution. Let's now look at the call trace for tail recursion. Let n be 3 for the count method. 3 is greater than 0. It prints 3. Recursive call is made with 2 as the value for n. This calls the count method with n equal to 2. 2 is greater than 0, so it prints 2. We now make another recursive call with n equals 1. We now call count with n equals 1. 1 is greater than 0, it prints 1. We now make a recursive call with n equal to 0. So we now have a call to count with n equal to 0. 0 is not greater than 0. So recursion ends and we get out of the if condition. Recursion terminates. Work is done during calling time. Let's now look at the call trace for head recursion. Let n be 3 for the count method. 3 is greater than 0. A recursive call is made with n equals 2. 2 is greater than 0. Another recursive call is made with n equals 1. 1 is greater than 0. Another recursive call is made with n equal to 0. 0 is not greater than 0. Recursion terminates for this value of n. We return to the previous recursive call with n equals 1. The line 4 executes, it prints 1. The recursive call for n equals 1 ends and it returns to previous recursive call where n equals 2. The line 4 executes for n equals 2. It prints 2. The recursive call for n equals 2 ends and it returns to previous recursive call where n equals 3. The line 4 now executes with n equals 3. This prints 3. The program ends. The work is done during return time.